We'll change the protocol on Chapter 3 here. Instead of having you pause in the beginning, we'll pause as we do each example. And then we'll eliminate the ones we're not going to do. So here, graph a point on this graph. And the point is this. So remember, it's an ordered pair, which is x comma y. So our x is first, which is the horizontal bar axis, and the y is the vertical. So we do -1, go over 1, and then up 3. 1, 2, 3. And you put a dot right there. So that one's pretty easy. So for example 2 now, they want you to graph this line. So pause it right now. Okay, it's in the form of y equals mx plus b. And this is slope-intercept form. So there is our y-intercept at -4. 1, 2, 3, 4 is right there, -4. And then our slope, which is our m value, is 2 over 1. So from this point we go over 1 up 2, get a dot right there, over 1 up 2. This is now our x-intercept, 2 over 1 up 2. I'm just getting enough points so that when I make my line, I get a nice line. Oop, that's better. Now for number 3, this is in standard form. ax plus by equals c. So when it's in standard form and the numbers are even like this, or they're sort of like this, we can use the x and y intercept t-chart. Now another fallback way is to solve for y, put it in this form and graph it. And now if we have x here as 0, y is going to be divided both sides by 3, and we get a 2. And then now if y is 0, x is 6. So 0, 2, 0, 2, our x-intercept, and then 6, 0, 1, 2, 3, 4, 5, 6. And I could go this way too. 1, 2, 3, 4, 5, 6, up 2, just to give me a better shot at my line here. Okay. Now for something like number 4, this is in the form of y equals b, where b is our y-intercept. So we know this is a horizontal line going through -2, and then any other point that you make. So when we draw the line, it looks like so. Now for number 5, as we look at that, again it's in slope-intercept form, but there is no b value out here. When there's no b value, b is a 0. So this is going through the origin at 0. Our slope now is a -2 over 1. So we go over 1 to the left and up 2, over 1, up 2, over 1, up 2. I'm just getting some more points here. In MATLAB, you only need 2 to make a nice line. All right, so there's our first 5 examples. Now for number 6 and 7, I don't think we're including this, but just to give you a little background, we'll do it. So here we know our 1 here. In this position, that's our y value. So this whole graph is going to come down and go through a 1 here. And because of this inside the parenthesis, it's going to, opposite sign, it's going to have its base right there. And then it just looks like a nice parabola. And this one, since there's nothing out here, this is going to be at this line, but again, because of this plus or negative 2 here, it actually shifts over, it goes here. And our slope is just 1, so it's going to be a line like so. Anything of absolute value type has a V shape to it. So neither of these graphs are linear. The ones we did above are. So again, pause the tape as needed. So for number 8, we need these two formulas, the slope formula and the point slope form, because we are to get these 2 points, find the slope, then use one of the points, probably this one, to put it in slope-intercept form, and then eventually in standard form. So this one's sort of a challenge. Let's do the slope. So y sub 2 is 0 here, minus 4, and x sub 2 is 5, minus, this minus, a minus 2 makes it a plus 2. So our slope now is a negative 4/7. So we're going to put the slope there as a negative 4/7 times x. Now I said I'm going to use this one, so this will be minus 5. And this is going to be y. And this is our y sub 1 here. Or in this case, the one that we're using. So this will be minus 0, or it's just that. I could put the minus 0 there. That'll be okay. All right. Now the first thing, because we want to put this in standard form, is to get rid of this fraction. So I'm going to multiply every term by 7. And I'm going to get rid of this 0 anyway. We don't need to do anything with that. So this is going to be 7y equals, now when I multiplied this side by 7s, the 7s cancel out, so that's a negative 4x plus 20. And to put this in standard form, I take my x term to the other side, where it becomes a positive 4x plus 7y equals 20. And that is correct. So again, a lot of steps for this one. We had 2 points, so we had to find the slope. And then we needed the point slope form to put it in its proper form, and then convert it to slope intercept, standard form, from slope intercept in a sense. Now, number 9, if we know it's a vertical line, well, the formula for a vertical line is y, no, let's do that one again, x equals a. And what is the value of a in our ordered pair here? Well, remember we said this could be written as a comma b. So our a value is negative 3. So for number 9, if we know this basic form of a vertical line, x equals a, then x equals negative 3. Now for number 10, since they are giving us the slope and then 1 point, we're going to use that point slope form. So y minus y sub 1, which will be a 3. Remember, negative is part of the formula, equals our slope, negative 7, times x, minus is in the formula, and then a 1. So this then becomes y minus 3 equals a negative 7x plus 7. As I go, negative 7 times negative 1 gives me a plus 7. Now I'm going to move this to the other side by adding 3 to both sides. I get y equals a negative 7x plus 10. Now to put this in standard form, I take this x term, bring that to the other side as a positive. And that should be our answer, and it checks out. All right, again, if you want to pause it as you get to work on the next one. Here we have a horizontal line now, so that's going to be y equals b. That's the form of the standard form of a horizontal line. Now we said b was in our ordered pair, a comma b is negative 2. So number 11 is y equals negative 2. So a couple of easy ones here. And now they're asking us to find the slope. Again, pause it if you want, but we'll use that formula. This is our y sub 2. So a negative 6 minus y sub 1, which is a 1, minus is in the formula. And then 2 minus is in the formula, a negative 3. So that makes us a positive 3. So this will be a negative 7 over 5. And that is my slope, and that is correct. Find the slope and the y-intercept of this line. Well, for this one, we're going to recall that if we put an equation into slope-intercept form, y equals mx plus b, whatever is in the m position is your slope, and whatever is in the b position is your y-intercept. So what we have to do here is solve this for a positive y, put it in this form. So the first thing I would do is get my y formed. I'm going to move the y to this side as a positive 2y. Move the 7 over to this side as a negative 7, just using transposition. And now to get y by itself, I divide everything by 2. And then I'll write it the proper way here. So this will be y equals, simplify that, 3x minus 7 halves. So my slope will be 3. Remember, it's just the numerical coefficient of x here when it's in this form. And my y-intercept is this. Now, depending how they want you to input the answer, this is what b is. But the formal way to do it, of course, would be x is 0, and then a negative 7 halves. That would be the formal way to list the y-intercept. How do they list it in the book? Oh, they list it just this way here. Okay, number 14, they want you to find an equation, but they want it in function notation. That's sort of like slope-intercept, but we put f of x instead of y equals this. So we have to find the slope first. So 4 minus a minus 1 is plus 1. 5 minus 2. So this is 5 over 3. And then I can use either of these points. So I'll go y minus, and we'll use this one here. A minus 1 makes this a plus 1 equals 5/3 for my slope. And then x minus 2. Now, I strongly suggest if you get away from fractions, that helps a little bit. So let's get rid of this 3 by multiplying every term by 3. So multiply this by 3, multiply this by 3, makes it a 3. Here, multiplying, this is all one term. The 3's just go away here, cancel out. So I get 3y plus 3 equals 5x minus 10. And now I take my 3 from this side, transpose it, that makes it a negative 3 there. So I get 3y equals 5x minus 13. And then now to get the y by itself, I divide everything by 3. So now to put it in function notation, f of x, which is y, equals the slope 5/3 x minus 13/3. And I just checked that, and that is correct. All right, we'll clear it up, and if you want, you can pause it, work on 15, which is to find the equation of a line in function notation that is parallel to this line, but goes through this point. So step 1 is to find the slope of this line. And we find the slope, you recall, by dividing, solving for y. Let's do that. So we have 4y equals, transpose the x, a negative x on this side, plus 2. Now we divide everything by 4. There's a 1 there. So we now have y equals a negative 1/4 x plus 1/2. Now we don't care about this, we just are interested in our slope. So the slope of this line is a negative 1/4, and we now have to have it going through this point. So I go y minus, a minus 7 gives us a plus 7, opposite sign, equals a negative 1/4 times x minus, am I on the right one here? No, I was copying the wrong answer, so this has to be a 3, so negatives in the formula, negative 3. And this was a negative 1, so it became a positive 1. Again, a good technique, get rid of the fractions. Multiply every term by 4. Here the 4's cancel out, and I get 4y minus 12 equals, this is going to be a negative 1x. We don't usually write the 1. And this will be a negative 1. So a negative 1 times a positive 1 is a negative 1. Okay. Now we're going to transpose this to the other side, and I get 4y equals a negative x. This over on the other side becomes a positive 12. Minus 1 is a positive 11. And then I have to solve for y, so I divide everything by 4. Now I can put the 1 there in a sense. So our last equation then will be f of x, putting it in function notation, equals a negative 1/4 x plus 11/4. And I checked it, and that looks good. You got to copy the right example down to get the answers, by the way, yes. Now, for number 16, they want us to find a line that's not parallel, but perpendicular. Okay, and we had said, if we find the slope of a line, and let's do that first. So this will be 3x, I'll bring that 1 over, plus 1, equals, transpose that to the other side, 2y. Now divide everything by 2 because we want to find our slope. We then get y equals 3/2 x plus 1/2. So we solve this equation that was in standard form, put it in slope-intercept. So this is the slope of that line. Now to find the slope of a line that's perpendicular, it would be the opposite sign reciprocal. We often say the negative reciprocal of that, so it's got to be a negative 2/3. So there's our point. Y minus a minus 7 makes it a plus 7. I have the right example now. Equals a negative 2/3. This is my perpendicular slope to this, and then in parentheses x minus 2. Again, a technique, get rid of those fractions, multiply every term by 3. Here the 3's cancel out, which is what I want, so I get now 3y plus 21 equals, so notice there's a negative there, so negative 2 times x, a negative 2x. A negative 2 times a negative 2 gives me a positive 4. Now I bring my 21 over and I get 3y. This is a negative on this side. Equals a negative 2x minus, remember this on this side's a negative 21, so this is a negative 17. And now divide everything by 3. And I'm going to convert this to a function symbol. A negative 2/3 x minus 17/3. Now again, the idea that you're going to pause the tape to work and you can go back and try it. This is what the benefit of this is as a study aid. Okay, we'll raise it up and go on and look for strategy to get these others here. Now determine if these lines are parallel, perpendicular, or neither. Okay, so again this is challenging because this is in slope-intercept. I'm sorry, this is standard form, and you would need to put it in slope-intercept. So let's do that. So I get 2y, and I'm going to transpose to make it positive. Bring over the 6 to this side as a negative 6, and this is 5x. Divide everything by 2, and I get that y equals, I'm rewriting it now, 5/2 x minus 3. So I know now the slope of this line. So now I have to figure out the slope of this line. So 2 minus a minus 1 makes it a plus 1. 3 minus 4. So this is going to be a 3 over negative 1, which is now a -1. So the slope of this is a -1. Now if the slopes were the same, the lines would be parallel. If the slopes were the negative inverse of the other, they would be perpendicular. But here, these are not the same. One's not the negative reciprocal of the other, so the answer is neither. Okay. Now, for something like this, where they're asked to find the domain, I usually go like this. The domain is what? Remember, domain are your x values, and the range are your y values. So even though as long as they don't have like dots here ending it, this indicates this goes on over in this direction of the x's to -infinity eventually. This goes way out there, it never stops, and eventually goes this way too, to +infinity. So that's the domain. Now how about the range? Range, again, are your y values, and if we project this dip here over to this, it looks like right there. So that is at, and I would say it includes that dot there, a -2 along the y-axis, and eventually we'll go up to +infinity. Remember, infinity always has a parenthesis. Now for number 19, again, this is an equation. As a little review, it will be x equals 3, which is a vertical line going through 3. So for domain, what value do you have? Well, you only have the 3. So this would be a 3, and I think generally they'll put it in brackets there. That's correct. But how about your y values for the range? Well, it's coming up from -infinity and going up to +infinity. So that one was a little easy. Now, we didn't do a lot of work with absolute value in Chapter 3, but we could do this function, I think, okay. So here they're saying our x value is a -2, and here it's going to be a 3. So if we put a -2 and replace it, that'll be a -2, and a -3 is a -5. The absolute value of a -5 is 5. So we have 5 minus 2 will be a 3. So for 20, it's going to be a 3. And then here, if you have a 3 there, 3 minus 3 is 0. Absolute value of 0 is 0, and you just end up with a -2. So again, some real easy ones, as long as you have a strategy to figure them out. Now, when we are graphing inequalities, I'm not sure we're going to have this in our unit, but let's just show you it if in the event they do get there. How would you solve this? Well, again, solve for a positive y. We're going to bring the y over to this side as a positive y, and our inequality sign doesn't change, and we're going to take the 5 and bring it over to this side. And then that stays like so. So if we write this the proper way, it's y is less than x minus 5. Okay. So if we graph this line, our y-intercept is a -5. 1, 2, 3, 4, 5. A dot right there. And our slope is 1. So over 1, up 1. Just getting a lot of points here, so I make a line. Now, when we graph an inequality like this. Our line tool is not a solid line when it's only an inequality like this. For we're equal, it's a solid line. Inequalities, we have a dotted line. So in a sense, we could use this as our dotted line. That's the line of the graph here. And there is a tool for that. Now, there are a lot of other answers here, so you have to shade in part of this. And which part do we shade? Well, the general rule, anytime you have y is less than something, you shade underneath. Okay? All right, this one is x equals 2, which is a vertical line going through 2. So again, this would be a solid line now, going through 2, because it's also equal to it, and it's x is less. Anytime x is less, you shade over on this side, the left. Okay, and I know we didn't do 24 and 25 for sure. So this wraps up our little review. A little shorter than the other, but hopefully it's helpful to you.